Okay, after we get the sine angle addition formula, which is this one right here, this one follows very, very quickly. If I just change this to a minus b, right, change the plus to a minus, then that becomes negative right there, and that becomes negative right there. And there are two properties about sine and cosine. Sine is an odd function. That says that sine of a negative something is the negative sine of that something. And cosine is an even function, which basically means that if you put a negative in here, it doesn't change the output at all. Why is that? It's because sine looks like this. So like this point corresponds with that point. Go negative, and we go negative, right? That's this negative and that negative. And then cosine is a function that looks like this. So if I go positive, bam, negative the same amount, right? Then they're the same thing. So that's what those two say. Anyway, do that, and this line quickly turns to that line. I'm not going to prove the cosine angle addition formula. This is what it is. But notice that it looks really similar to this. The proof for this is very similar to the proof that you just did for the previous one. So if you can accept that, then we use the even odd properties again, change this b to a minus, and we get this negative cancels out because of that. That guy right there comes out and we get a double negative. And then the cosines do not change. So this just goes away. So once I have these four, I can do a lot of work to get, or not a lot of work, I can do just a little bit of work to get all of the formulas that we've talked about above. The first one is I can do the cosine of 2a. If I do the cosine of 2a, then what I can do is just take this a and that, sorry, take this b and make it an a. What do I get? Cosine of a. I'm going to drop the parentheses. So that's this first one times another cosine. Remember this b right here, if I change it to an a, I get a. And then minus sine a, that doesn't change. So sine A, and then the sine B, I get a sine B. And then what that gives me is that the cosine of 2A is equal to cosine squared A minus sine squared A. And that is one of our double angle formulas from above, up, where is it? Right there, cosine squared minus sine squared. So we got that one down. Now we're going to do the one for sine. You might see how to do sine's double angle formula. I'm going to take this one, right? So let's just think about it, right? If I make that b an a, right? Then well, I guess I'll write it out. I get sine of a plus, or sorry, and we'll write it as sine of a plus a equals. All right, what do I get? Sine a cosine a plus, what do I get here? Sine, the b turns to an a, cosine a. Notice what this gives me is that, whoops, the sine of 2a is equal to, there are two of those, they're the same thing, 2 sine a cosine a. So notice, boom, I've got the other double angle formula right there. And that matches this one right here. Bam, right? Because that's a multiplication. So now I want to get these guys, right? So let's come down here again. What are we going to do? I'm actually going to take this one and do some variations of that, and that's going to give me my power reduction formulas. The power reduction formulas are the ones that are most important for us as we move forward through multivariable calculus and into double integrals. You should know that sine squared a plus cosine squared a is equal to 1. So notice I can solve for sine squared a. That gives me sine squared a is equal to 1 minus cosine squared a. Now what I can do is take this sine squared and replace it with this stuff right here. So if I do that, so I'm going to, and I'm going to slide that in, I get the cosine of 2a is equal to cosine squared A minus, and then I'm going to fill in this guy right here. So 1 minus cosine squared A, correct? Yep. So from here, notice I've got a minus 1, but then I've got a minus double negative right there. So a double negative cosine squared. Well, I've already got one cosine squared there. So what do I get? I get cosine of 2A is equal to cosine squared, or sorry, 2 cosine squared A, not plus, minus 1. From there, I can solve for cosine squared A. I'm going to move the 1 over. So I get 1 plus cosine 2A, and I'm going to divide by 2. So if I solve for cosine squared A, I get 1 plus my cosine of 2A all over 2. And that is my power reduction formula for cosines. Notice this matches what I have right here, 1 plus cosine 2x, right? So now let's do the sine x. Come down here. So there's actually kind of lots of different ways to get to the sine squared one from here. I'm going to kind of use this idea right here. I'm going to use the Pythagorean identity again. So notice if instead of sine squared, I solve for cosine. Instead of sine squared, I solve for cosine squared. I would get cosine squared A equals 1 minus sine squared A. And then what I can do again is go and do some replacement. This cosine, this cosine squared is going to get replaced with that. So when I do that, I get 1 minus sine squared A is equal to, I'm going to write it as 1/2 plus cosine of 2A all over 2. The first thing I'm going to do is move the 1 over. That's going to make this a negative 1/2 because I'll subtract it. So minus sine squared A equals negative 1/2 plus cosine of 2A all over 2. And now, look, I can negate everything. And I get sine squared A is equal to 1/2 minus, right? Just divide by negative 1 everywhere. This becomes positive, this becomes positive, that guy becomes negative. Cosine of 2A all over 2. And then I can just combine them into the same fraction, and I'll do that over here. And I get that sine squared A is equal to 1 minus cosine of 2A all over 2. And now, bam, I've got my two power reduction formulas. So hopefully you can see them, you can remember them, how I talked about them in the previous video, and then also you just see why they're true. I don't want to just throw a formula at you and not have you understand or have been through the process of showing why it's true. Because now that we've got these, we can do a whole lot with them. So in the beginning of this, I posed the question, like, how are we going to integrate sine squared x? So now that we have these power reduction formulas, it's something we can do. All I do is change sine squared x over to this. So I get that is the same as the integral of 1 minus cosine of 2a. And then I'm going to write it as 1/2 and over 2 like this, just because it's a little bit easier to integrate. And what's that give me? Or sorry, not A's. Okay, this should be an X, not an A. So what is that? That's 1/2 X dx. And then cosine integrates to a, you got to really be careful with your negatives and positives, and you'll get used to it over time. But this is a cosine, which would integrate to a positive sign, but it is negative. So we get negative sine of 2x, and then I got to deal with my chain rule over 4 plus a constant. So now I can integrate something that I couldn't integrate before that is going to come up all the time. Okay, so we're going to do one more here. I think I can fit it into 5 minutes. We're going to do the integral of sine squared x times cosine squared x. Now, there's not always a way to go, but I think you'll get used to it as we go along. This one. So, look, what I can do is I'm just going to do some side work over here. I'm just going to rewrite this until I get it into a form that's integratable. So sine squared x times cosine squared x. Well, that is equal to, I'm going to use both formulas. The sine squared is 1 minus cosine 2x over 2. This one, 1 minus 1 plus cosine 2x over 2. So that is equal to 1 minus cosine of 2x over 2 times 1 plus cosine of 2x over 2. And then look, that is, all right, I got a 1 over 4. You should see that. And then I'm going to open a set of parentheses. And look, do you see that this is, if I had x plus 5 times x minus 5, that would be difference of two squares. It would FOIL out to difference of two squares, x squared minus 25. You should see that this is 1 minus cosine times 1 plus cosine and they are being multiplied there, right? So it takes the same form. So what do I get? I get 1, and then I get minus cosine squared of 2x, close. And now, the question is, how do we deal with this? Well, I need to take this thing right here. That's not integratable, right? I want to get it to a form that's integratable. So now I got to use the double angle for the power reduction formula again. Anytime we get something that is even like this, we're just going to reduce, reduce, reduce. So I'm going to rewrite this as 1/4 minus cosine squared of 2x over 4. Now, let me pause for a moment. Now, I copied the double angle or the power reduction for cosine squared. What I want you to see is that I need to reduce a cosine squared that already has a 2x in it. So if this right here is that one, then notice this piece is this piece. So a is equal to 2x, right? Notice this says 1 plus cosine of 2a. So that means that 2a is going to be, well, I got to double both of them. I get 4x, right? So what am I going to get? I'm going to get 1 over 4 minus, I'll write 1 over 4 times 1, remember cosine gets a plus, cosine of, right? And now the power reduction takes me to 1 plus cosine of 2a. Well, 2a is 4x. So I get my 4x all over 2 like that. Hopefully you see that, and I think that with more practice that'll come, right? But it was this in here was the and it says 1 plus cosine of 2 So what's 2 It's 4x. From there, I get 1/4 minus, how do I want to write this? 1 over 8 times 1 plus cosine of 4x, which is going to give me, all right, let's look at this. This is 1/4 minus 1/8, right? You should know that 2/8 is a fourth, so if I take a fourth minus an eighth, I'm actually left with 1/8. And then minus cosine of 4x all over 8 once I distribute that 1/8 in. So now what I'm going to do is copy this and come up here and paste it there, move it over a little bit. All right, so I am doing the integral of that dx. Because remember, I started with this, I did a whole bunch of work to get down to this, and now I've got this thing, right? So let me get rid of this. So when I integrate this, we get 1/8 x, and then it's the same thing as above. It's still going to be negative. I'm going to have a cosine of 4x, and then in the denominator, I need to multiply this 8. Sorry, I did that wrong. This should be a sine of 4x. I integrate the cosine to a sine, and in the denominator, I'm going to multiply the 8 by this coefficient and get 32. And hopefully you see how we can use these double angle formulas to integrate things that otherwise we would have never been able to do before.